Yeah, boy. Today is Veterans Day. I don't even want to write the year because that would just ruin the beauty of 11/11. Look at how nice that is. This is going to take us this is a multiple day journey. So we're going to do absolute value still. Inequalities. I have two versions of this lesson. I have the one that I taught for 27, 28 straight years. And then I had a new version that I tried last year, and I thought that it was actually a pretty successful year. So you guys are going to get the new and improved version. Um, if this doesn't go well, and I usually have a pretty good sense, and you guys could be pretty open with me about whether or not if you feel the vibe of the lesson, then I could try tomorrow to teach you a different approach. Uh, but this one I feel like is a little bit less dangerous. It might be a little bit tiny more work, but I think it's more solid, I think. So let's get started by just talking about the basics of this. So if I gave you the absolute value of x and I told you that it was greater than or equal to 5, we fundamentally have to truly understand what absolute value means. And I said something about this a couple of weeks ago about how we can't think of absolute value as that thing with the bars that makes negative numbers become positive numbers. That definition will. You're done. What does it mean again when I say the absolute value of x? Mm-mm. If I said to you, what's the absolute value of 3? What do you think of? It's 3 away from 0. Yeah, and I don't mean like, what do you think the answer is? I mean, like, the conceptual idea of the absolute value is how far numbers are away from 0 on the number line. So if I say to you, I'm thinking of a number x, and his distance from 0 is greater than or equal to 5. What you do is you start to generate an image in your mind and ask yourself, what kind of numbers are great? What kind of numbers are 5 or further away from 0? And to teach this lesson, no matter which version of this lesson you get, there's zero chance that I'd ever not introduce it with a number line. So what I'm going to do to help you understand this is I'm going to place 0 in the center. And I'm going to ask you to give me a number that satisfies this requirement. Go ahead. Pick 5 works for me because of the stipulation of or equal to. Because I say my distance from 0 has to be more than or equal to 5, then I say, well, 5 is good. Give me another number that's 5 or further from 0. Did you say 6? Sure. Give me another one. Ooh, 6, 7. I like that. What else? I assume you did that on purpose. Nice. What else?
11.
Hmm?
11.
Sure. I see that you guys, for some odd reason, are insistent on heading. Thank you. Dare we forget that we can also go to the west? So I heard a -6. What else? -7. Way to jump on both of those opportunities there, J Ball. Good work. It's good, solid. Could I do -5?
Yeah.
What we start to generate here is an image in our mind of there's essentially like a blast radius that's happening at 0. And all of the numbers within a certain blast radius are being destroyed. They don't count. Like, why could I not say 3? Because it's not 5 or further away from 0. It's too close. If we sat here and did this activity for another 10 minutes, eventually we would saturate our number line with points. How many points are there? Well, there's infinitely many, but the stipulation is that I can be at -5 and I can be at 5, correct? Or I can be anywhere to the left of -5, or I can be anywhere to the right of +5. And if you sit here and do this long enough, you start to generate this exact picture, and you should copy that down.
Pretty sure I remember.
That picture right there is an indication of all of the numbers in the universe that satisfy the requirement of being 5 or further steps away from zero. This you'll come to know in my class. Don't worry, you're going to hear this word a lot over the next, like you are going to say it and I'm going to say it hundreds, hundreds of times. It's not a real math word, by the way. I started calling them splitters a long time ago, or it just seems to fit. The reason I call it that is because for me, visually, it feels to me like the graph is quite physically splitting away from itself. It splits in one direction and the other direction. But the graph has to go outwards because we need the distance from zero to be outside of a certain boundary, not inside. Got that? Okay. The next math question I have, oh, by the way, I should tell you how to write down the answer to this. I almost forgot that. We're going to write this as x is less than or equal to -5, or, and I'm going to double underline the word or, x is greater than or equal to +5. That is how you write a splitter. Okay. Second math problem is going to look like this. I'm thinking of a number x whose absolute value is less than 4. If we translate that, again, it's without an understanding of what absolute value is, we would be lost here. But what am I asking you for? If I say find me an x, what does your x have to be? Describe him to me. Finish that thought. Less than 4 what?
Wait.
Yes. And so again, I'll put 0 in the center because he seems to be in on all this action. He's the center. He's like the place where the action occurs, right? So I can be close to 0 this time, but not far away. So for me to say I'm thinking of a number whose distance from 0 is less than 4, let me ask you a question. Does -4 count?
No.
It does not count because -4 is too far away. This distance is exactly 4, and according to this requirement, my distance has to be less than 4. So in math, you'll remember this from Algebra 1. If I want to show a point on the number line that marks a boundary but doesn't count, I put a circle there, but I leave it wide open. I do not color this in. This will look familiar from Algebra 1. What's the boundary on the right-hand side? +4. And again, what I'm doing is I'm setting boundaries as if to say, this is where things start to be true or false. These mark the boundary between truth and lie. Where are the numbers that are less than 4 steps from 0?
Between 0 and 4.
Over here? So I agree, all those points would work that I just colored red. What other points would work?
Here.
It's from 0 to -4. Does 0 work? Of course, 0 steps from himself. 0 is less than 4. What we come to see is that this graph looks like this. All of the points, bless you, Jack, all of the points in that shaded region have a distance from 0 that is less than 4. So this time, rather than it being like a blast radius that's forcing numbers away, this is more like a big, powerful magnet that's sucking numbers towards it, and its strength is defined by the width of the boundaries. This one is called, again, I don't know that anyone else in the universe other than my students and myself say these words, but we'll come to know this as a squisher. It helps us when we're talking casually about, hey, is number 4 a squisher or a splitter? Like that's the terminology that we're just going to casually use. So this one is going to be called a squisher. And the way we write this one, you're not going to like this, is -4 is less than all x's are less than +4. Whenever you have a squisher, you want to write it as a conjoined statement like this. What it is it's an implication of two things that are both true. Read what I'm underlining in yellow, but say it from the x side. What does it say? From the x first, please.
X is greater.
It says quite literally that x is greater than -4, and that's true because I am coming to the right of -4. Read this one I'm underlining in purple from the x. X is also less than 4. Because both of those have to be true, that's why those two forces collide and create like that sea of points in the center. I'm essentially capped on the lower and upper ends to the inside. So to recap, splitters will be written with the word or. Squishers will not be written with any words at all. There is no word. There is one continuous compound inequality that is written like this. Got it? So that is your quick and awkward introduction. And now we're going to do 4 math problems, and I'm going to show you how to actually do math problems like this. Let's get to it. I'm going to walk you right through the steps. I'd like you not to take liberties with these steps, as some of you demonstrated on the quiz. You're just like, yeah, I'll do it my own way. I don't recommend this. Kind of hang with me here, okay? Come along for the ride. What do you think step 1 is? Step 1 is to get the absolute value by itself, which, as you can see, is not applicable to this problem because it already is. Step 2, what we're going to do, and this is the new method that I learned last year, and I kind of like it. What we're going to do is we're going to take, and in our minds, we're going to replace this with an equal sign. And then we're going to flex on the math gods and show them that, hey, I know how to solve an absolute value equation. I'm going to split this into 2 equations. What I'm searching for right now are the boundaries. So one of my equations is going to say x minus 4 equals 13. What's my other equation going to say?
It's also, or
I'm sorry, I don't know why I put -4. I apologize for that. If you're wondering why I put minus, it's because I'm a bonehead. I meant to put x plus 4. What does my other equation say? X plus 4 equals -13, right? Sorry for the blunder there. Let's solve these equations. What does the red equation come out to equal? 9. We found a boundary. Let's go to the purple equation. What does x equal? No.
oh,
Do gooder. -17, for God's sake.
oh,
So what we're going to do now is we're going to draw a number line. So I'm going to go over here off to the side, and you're going to do it with me. We're going to make a number line. And we're going to put our boundaries on the number line. I'm going to put -17 over here, and I'm going to put 9 over here. I want you to notice that I'm not going to worry about 0 anymore. If you like that kind of thing, you can. The trouble is we're actually going to have problems where 0 won't even be in the picture. So let's just worry about our left boundary and our right boundary. How many regions did I just break the number line up into? 3. We're going to call this region A. We're going to call this region B. And we're going to call this region C. Now, what we're going to do is we're going to test a point in each region to see if it's true or false. And by testing points, we will get a quick picture of where should I shade. I say there's a total other version of this lesson that I'm keeping pocketed for now. Okay, so give me a point that's in region B. 0 is fine with me. We have to all agree, we're all big kids here, that 0 is somewhere between -17 and 9, right? So let's take 0 and put it right where the green arrow is pointing. What is 0 plus 4? What is the absolute value of 4? Is 4 greater than 13? Therefore, you will not shade in the region between the boundaries. Every other point you pick between -17 and +9 will yield the same results. So we already have an idea that if I'm not going to shade in here, then I'm probably going to shade outside, right? What do you think this is going to be, a splitter or a squisher?
literally.
It's going to be a splitter. Let's verify that. Let's take a number. Give me a number that's in region A.
19.
I love -19. Let's put -19 up where the green arrow is pointing. What is negative 19 plus 4.
Negative 15.
What is the absolute value of negative 15?
15.
Is 15 greater than 13?
Oh, yeah.
So we have discovered now that we should shade on this side. I'm going to put an open circle here, and I'm going to shade that side. Just to finish our graph and make sure that we're not wrong about our assumption, let's test a point in region C, just to make sure. Give me a number that's in region C.
11.
11 works for me. You could have said 126,915.6. I don't care. If it's to the right of 9, it works for me. Let's put in 11. What's 11 plus 4? 15. What's the absolute value of 15? 15 is greater than 13. We have found another truthful region. I will tell you this about inequalities. If you find a point in a region that is true, every other point in that region will also be true. That's why it's so essential that early on we find these boundaries. Those boundaries are not the answer to the problem. They're just kind of the beginning point, the structural beginning. And now finally, we have to actually write the solution. How would I write this solution according to this number line? What would I say?
Greater than.
Or x is greater than 9. Good. Got it? Should we have known that the graph was going to look like this? Hint, hint. Yes, because of the first part of the lesson. If you were paying immense amounts of attention, then you know that there's a relationship between the greater than and less than and the type of graph that it creates. Let's go again. The absolute value of x minus 8 is less than or equal to 12. What do you think this is going to be?
Swisher.
Thinking it's going to be a squisher. Since we're new in this lesson, let's validate or verify that by just doing some real simple math. So rather than thinking of this as an inequality, let's just temporarily get rid of this sign and call it an equals. And let's do what we did on yesterday's quiz. Let's make two equations. One of them is going to say x minus 8 equals 12. What's the other one going to say?
8 equals 12.
Heck yeah. And now let's just do some fundamental math and solve these boundary equations. On the left side, what does x equal? 20. On this right purple equation, what does x equal? Negative 4. And those aren't answers. Those are boundaries. So what I'm going to do is I'm going to go draw a number line. And I'm going to mark just my boundaries is all I care about. Negative 4 is obviously to the left of 20. Duh, right? What kind of circles am I going to have? Colored in or open? Colored in for sure, because the or equal to in the problem tells me that my boundaries will work. They're in play. So we're going to color in our boundaries. And our theory is that we should shade in the middle. Let's test a point in the middle to validate that. 0 is in play again. Let's take 0. Put 0 where the green arrow is pointing. What's 0 minus 8? What's the absolute value of negative 8? Is 8 less than or equal to 12?
Yeah.
The fact that that point is true means that every point in this region will be true. And real quickly, you should test a point in regions A and C just to verify that they're no bueno. Give me a point that's in region A, the left region.
-6.
Negative 6 works for me. If you put negative 6 in there, what's negative 6 minus 8? Negative 14. The absolute value is 14. 14 is not less than or equal to 12. The same thing is going to happen on the right. Give me a number to the right, like 30. What's 30 minus 8? 22. The absolute value of 22 is not less than 12. Therefore, we've proven that this is what we want. How do I write this solution? Yes. Notice both of your Pac-Mans will waka waka to the east, okay? They are not dueling Pac-Mans. They don't face each other. They don't oppose each other. They both waka waka to the east. And when you read these like an expert, you do not pause. You say negative 4 is less than or equal to x is less than or equal to 20. You're saying two things at once. Now, two more examples. Got it? And then tomorrow will be a work day. Say what? Did someone say something about the number nine? What just happened? You guys are weird. Oh,
So,
so this goes back to what we know about absolute values. I'm going to ask this question again because it's more pertinent now. What is step one? Yeah, we need to get the absolute value by itself. That has been and will continue to be our battle cry for the foreseeable future is if you don't get the absolute value by itself, you won't pass. The first thing we have to do is get rid of this six. And some of you really need to listen closely to this explanation as to how we do the algebra to get the thing by itself. Step one is we subtract the six because it's the straggler. We remember this from algebra. So we're going to take away six. You do not touch the five yet. So we are left with five times the thing we're trying to get by itself is less than 10. Now it is time to murder the five. And how do we do it? Say again. You divide by five because it's a multiplier. And when we want something like that gone, we kill multipliers with dividers. Got it? Now that we have the absolute value by itself, it is time to go Splitsville. So we're going to, well, let me say this. Do you have any questions so far? So we're going to, in our minds, just think of the inequality sign as an equal sign, and we're going to go back to the old standby. We're going to go Splitsville. What does my red equation say?
7,
7 minus x
1, or equal to.
is equal to 2, right? Remember, this is where this lesson differentiates itself from my old self. And I'm finding a lot more success if we don't tinker with the inequality as much. Let's think of it as an equation just to set our boundaries. What is my purple equation going to say? Good. And this is some pretty rinky-dink basic algebra stuff here. For this red equation, I'm going to pull the x to the right and the 2 to the other side, giving me x equals 5. For the purple equation, I'm going to pull the x, and again, basically having the x and the 2 switch places because I want that x to go positive, right? So x is going to equal 9. Good, good. Based on this, do you conjecture that this will be a splitter or a squisher? Are you starting to make that connection? Are you starting to see that when we're at that end stage where we make that declaration, the thing in the big yellow box, that could give us an indication as to what our graph's going to look like? Old me relied on that too much. New me is like, nah, let's play it safe. Let's test a region just to make sure that what we think it's going to look like is what it actually looks like. So let's do our due diligence. Let's make a number line and let's test a point where we claim we're going to shade. I'm going to mark my boundaries 5 and 9. And you think it's a squisher?
Yeah, you know.
Let's put our money where our mouth is and let's try it out. Give me a number in the squisher region between 5 and 9.
36.
6 works for me. You could have used 6 or 7. That was just for you, Jackson. Yeah, boy. So 6 is fine. 6, 7, whatever. You could do either one. If I put 6 up here, and I'm always torn in this part of the lesson, safely, you should put it up here. Why? This is a tough one. Answer this question carefully. Why is it maybe not the best idea to put it here? Who made the yellow box? You did, and you're a human. And there's a decent chance that as a human, you might have made a boo-boo in the course of going from the original problem to this. So if you want to play it next level safe, put your number back in the original problem. But honestly, if you feel confident in your ability to do basic math, then you can test it here. If we always are like, yeah, I didn't make a mistake, I'm good, then we can test it here. Let's put 6 in there. What's 7 minus 6?
1.
What's the absolute value of 1? Is 1 less than 2?
Yeah.
Because that's a true point, guess what? They're all going to be true points. And so we're going to hollow circle these boundaries because there's no or equal to in the problem. And then we're going to shade the region that we thought. And again, just to be safe, you should test a point on the left and the right, and you'll see that they do indeed both fail. Let's do one more as quickly as we can. Last one, -3 times the absolute value of 10 minus 2x. Whoop. Plus 6. I don't know why I did plus 6 again. What a weirdo. What do we do first? Get rid of that 6. Move that 6 to the other side. So I'm going to now have -3 times the thing I'm trying to get by itself is less than or equal to -6. Now what do I do? Divide by -3. And this is a dangerous part. I'm about to do something I wish I hadn't saved this for the end of the lecture, but here it goes. Does anyone by chance remember from Algebra 1 something crazy that happens when you divide both sides by a negative number? Nope.
The thing switch.
Thing switches. Yes, the Pac-Man takes a whoop 180, and because we divided by a negative, we're going to now have the absolute value. Nice job there, Ryan. We're going to have the absolute value of 10 minus 2x is, wait for it, greater than or equal to 2. Woo!
Getting spicy.
Spicy. So we're going to make a number line. What do you think it is? Why do you think that? Because it says greater than right there. And this is where old Mr. Ahern was a worse teacher than new Mr. Ahern, because if old Mr. Ahern relies only on that sign, then we might wind up forgetting to change our sign because we're human and our graph just is completely wrong. So that's why we're going to test regions and go with, is our theory good? So we're going to set equations. One of them is 10 minus 2x equals 2. One of them is 10 minus 2x equals -2. And then we're going to solve. This one, 2x is 8, x is 4. This one, 2x is 12, x is 6. So we're going to set boundaries of 4 and 6. Open circles or closed circles?
Whatever.
Closed indeed. So let's color in our circles. And you think that it's a splitter?
Yes.
Let's test a point in the middle. And if the middle fails, then we can assume that the outers work. Give me a point between 4 and 6.
5.
I love 5. Let's put it right where this green arrow is pointing. Right there, 5. Boop. 5. What's 2 times 5? 10. What's 10 minus 10? What's the absolute value of 0? Is 0 greater than or equal to 2?
No.
Therefore, this region is false, implying that these two regions are true. And I went over my time, but you guys are awesome. And the bell would, if there were a bell, it would ring in 3 seconds. There isn't one. So pack up yo stuff and head to second hour. See you later. See you tomorrow. Veterans, I think. Because of the Veterans Day breakfast, I think it has something to do with that. I think so, yes.